Have you wondered what are the reasons that some firms might resist to technology change, new innovation, new processes, new products, and so on? Or have you also investigated why some firms are better than others in promoting innovations, and whether in some cases incumbents, so the firms already in the market, might have the upper hand in promoting new innovations, or in other cases could be the new entrants in the market that will come up with some innovation that might even be labeled as a disruptive innovation. And also, quite interesting, have you wondered why some technologies improve faster than the customer requirements? This is actually something that the former CEO of Intel, Andy Grove, mentioned a few times, that firms sometimes they come up with new innovations, new product development, new processes, and they are even faster than what the market requires. We will see this later on in the video. Innovation can take many forms and can follow many different paths. So there is no one single way to identify new innovation trends and then as an organization to promote new innovations. We know that innovations can come from many different sources, from the market, from consumers, from our R&D department. However, on the bright side, it's possible to detect some categories of innovation. And especially what we are going to see in the video is three categorizations. The first is radical versus incremental innovation. The second categorization is competence enhancing versus competence destroying innovation. And the third one is architectural innovations versus component innovation. What you will learn in this lecture is, first of all, how to distinguish different types of innovation, different innovation areas, possible scalability of new innovations, and how these innovations can achieve a dominant design. You will also learn how to play around with the three categories that we have just seen: radical versus incremental, competence enhances or competence destroying, and architecture versus component innovation. We will see also technology S-curve, the two different S-curve of technology, one related to technology performance and the other one to technology adoption, and as a result of the S-curve, the different cycles of technology and the definition of a dominant design. Without further ado, let's now move on to this lecture. Innovation can be really categorized easily. However, we can come up with what we call a technology trajectory. A technology trajectory is essentially a path, a pattern for innovation to be incubated and then developed by companies. Following this idea, this concept of technology trajectory, so we can identify these three main categorizations of innovation. As we say, the first one is product innovation versus process innovation. So both of them are very critical. Both of them are intertwined, deeply linked to one another. So in many cases, when you have a product innovation, then this can also lead to a process innovation in the other way around. A few clarifications that may help you understand better this concept. So when we talk about product innovation, we refer to all the new product development, all the new features. And this does not mean that we are only talking about physical products. So an example of a product innovation can be the new filters on Snapchat. Snapchat is a messaging application, so it's actually a service, it's not a physical product. However, we will still define new features introduced by Snapchat, or for what matters could be TikTok or Instagram, as product innovation. Process innovation is how we create new innovation, how we optimize the processes, how we make better, more efficient, more cost-saving processes for new innovations. An example here could be the adoption of automation, robotics. Tesla is a company that has invested consistently in process innovation. They basically automated all their product lines, especially for the Tesla 3. So this is a very good example of a process innovation. Product and process innovation push one another. So when we have a product innovation, this will lead to a process innovation and so on. Second categorization that we would like to see is related to the radical, the novelty of innovation. And this is the dichotomy between radical innovation versus incremental innovation. How can we define radical innovation? I will say there are two main elements to identify radical innovation. The first one is the newness. How novel is the new innovation? And the second one is the differentness, meaning how distinctive, how unique is this new innovation. Whilst when we refer to incremental innovation, this will be an adjustment of existing products, an improvement of existing products. Specifically on the concept of radical innovation, we need to analyze two important factors. The first one is the risk. Compared to incremental innovation, that is a way to react, to adjust to new market conditions, a new competitive landscape, for radical innovation, there is a strong component of risk. It's a risk related to the technology, but it's also a risk related to the market, competition, user acceptance, and so on. Example of this could be in telecommunication, the different stages of development of telecommunication, 3G, 4G, and at this moment 5G, and in the coming future 6G technologies. So in all these circumstances, in all this advancement of telecommunication technology, we have seen some key factors. For example, the bandwidth, so higher bandwidth of a connection that enabled the transfer of data, even video calls and so on, in a much faster and much more stable way. Of course, this implied that the technology devices, tablet, mobile phones that we use to transfer this data also needed to be updated. So if you are a telecommunication company, when you are about to introduce to the market 3G, 4G, or 5G technology, or for what matters, 6G technologies in the coming future, you need to consider all of this. The new technology have, of course, much more effective features. However, also all the devices that will use these technologies need to be upgraded. If you're using old mobile phones, even though a 5G connection can enable lower latency and higher bandwidth and so on, it doesn't mean that these can work with all the devices. So to introduce this new technology, you need all the devices to support the new technology. You need the infrastructure. You need to build the infrastructure for 3G, 4G, 5G. You also need the user adoption. So you need people, you need companies that are seeing the potential of a new technology and they are adopting the new technology. So as you can see, when it comes to radical innovation, the dimension of risk is extremely crucial, extremely relevant. The second point to analyze is the context. What is a radical innovation? And I think that here we need to specify who is looking at the innovation, who is looking at this radical innovation. Is it from a consumer perspective? Is it from a company perspective? In which company? Because for some companies, an innovation might be radical, but for other companies, this innovation can actually be just an incremental innovation. Example for this is the introduction of digital cameras back in the 90s. So when digital cameras technology was introduced to the market, the two market leaders, Sony and Kodak, they introduced almost at the same period of time their digital cameras. But for one company, Kodak, this was a radical innovation. It was a radical innovation because Kodak did not have any experience in electronic devices. So the company had to build all the capabilities to come up with a new digital camera. But for the competitor, for Sony, this was more of an incremental innovation because historically the expertise, the capability of Sony have always been in the area of electronic devices. So again, an innovation might be radical for some companies, but in some other circumstances, in some other companies, might only be an incremental innovation. Here, the key factor to consider is the competencies. What are the competencies of a company? And this leads to the second categorization. The second categorization is to differentiate whether a new innovation is a competence enhancing innovation or whether the new innovation is a competence destroying innovation. The example that I just shared with you, the example of Kodak and versus Sony. So of course for Sony, introducing the digital camera was a competence enhancing innovation. Sony built upon its existing capabilities to create a new product. But in other cases, we actually have the opposite. So we have a competence destroying innovation. Competence destroying innovation means that once this innovation has been introduced to the market, then existing products and even existing processes will eventually disappear. Think of a slide rule that has been used for centuries by engineers, mathematicians, and so on. In this until mid of the past century, mid of 20th century, when calculators were introduced to the market. And so slide rule disappeared from the market. This was very powerful example of a competence destroying innovation. All the competencies, capabilities the companies, people, experts built over a few centuries by deploying slide rules were destroyed all of a sudden. The third categorization is architectural innovations versus component innovation. Component innovation can also be defined as modular. So component innovation refers to the innovation in all the components, the parts that made a product. Let me give you an example because I think that could probably be easier to grasp. So think of a bicycle or think of a car. You can really see all the parts that make up a car or a bicycle. The wheels, the steering wheel, the engine, and so on. So what's the difference here between a component innovation versus an architectural innovation? So component innovation means that we are innovating only in some parts, whilst architectural innovation refers to the change of the entire architecture of a product, which means this is also a change of the design of a product. So to stick to the example of bicycles, if we are just improving some parts of a bicycle, for example, if we are improving the gear of a bicycle, so this will be a component innovation. We are not changing anything of the architecture of the overall design of the entire system of a bicycle. However, if we are moving from a bicycle without any electric motor to a bicycle with electric motor, so this innovation might have an impact on the architecture as well. Or even a better example, if we look at the past, 100 years ago, there were these interesting bicycle with a very big wheel in front and a very small wheel in the back. So why did this bicycle adopt this architecture? There was a technical reason, because back then there was no gear. So that was the reason why, since there was no gear, so the front wheel was so big compared to the wheel in the back was a small one. Once the architecture was completely overhauled and shifted to the existing architecture of bicycle, which by the way did not change for over 100 years, so with two same size wheels in front, in the back, so all the components of a bicycle changed. And of course you will say the wheels change, this is obvious, this is easy to observe, but many other components change as well. For example, the suspension of a bicycle, they were completely updated, almost invented by the new architecture of a bicycle. The gear also was invented with the new architecture of a bicycle. New companies were born thanks to the new architecture of a bicycle. A major consequence was the creation of tires, high performance tires. A company like Dunlop, that still equipping many of our cars for the tires, was born precisely after this change of architecture. So here are some key points that I would like you to remember. So of all these three categorization, so generally we can see that radical innovation and architecture innovation go hand in hand. So they are generally two types of innovation that share a lot of similar characteristics. So we can say that a radical innovation oftentimes is an architecture innovation. Another important point to consider is that all these categorization depend on the point of observation, the perspective. Let me give you an example. Electric vehicles, EVs. For a traditional car maker, make new electric vehicles might be a combination of architectural plus radical innovation. They need to come up with a new architecture for electric vehicles, and this for a traditional car maker is also a radical innovation, a new paradigm. However, if we look from the perspective of users, this might be perceived as an incremental innovation, because for users, an incremental innovation means just some additional features, and if you are a user, you don't see all the major changes in the architecture of electric vehicles, so you don't see all these happening, and you may perceive that electric vehicles are just a major feature improvement of existing vehicles. The next topic that we need to analyze refer to S-curve. So S-curve are exactly the type of pattern, the type of trajectory that technology will generally pursue. We can distinguish between two different S-curve. The first one is a technology performance S-curve. What does this S-curve assess? This S-curve will assess the improvement of a technology based on the amount of money, the amount of efforts to improve this technology. The second one is technology adoption S-curve. So this S-curve is more related to the market, and this S-curve will assess the usage of new innovation, the cumulative usage of new innovation by users, by consumers in the market. So let's take a look first at the technology S-curve. So the technology S-curve will tell us essentially what level of performance over a period of time a technology will be able to achieve. Based on the studies on S-curve of innovation, the theory states that eventually every technology will reach a limit. This is the end of the S-curve, and this is when a new technology will come in. So why the S shape for technology improvement? The reason is that at the beginning there will be a lot of investment, so a lot of effort to increase the performance of a new technology. And as soon as there is a better understanding, more experience for the new technology deployment, so then there will be an exponential growth of a new technology. The theory states that technology will eventually reach the limit, but this is not always the case. So in some cases, there might be a new discontinuous technology coming in and eventually replacing the existing technology. Why this happens? So it could be that a new technology, discontinuous technology, is coming into the market. It fulfills a similar market need, but it's using a completely new knowledge base, a completely new technology that might even be more effective than the previous technology. So then this S-curve will grow in a steeper way compared to the previous S-curve. Other thing to consider is that this discontinuous technology at the very beginning may even have a lower performance compared to incumbent technology. In this answer one of the question which we opened this video at the very beginning. So why some firms are reluctant to adopt new technology? So this could be because at the beginning the new technology may have a lower pace of development compared to existing technology, and so firms are reluctant to jump into the new S-curve of technology performance because they still depend on the previous technology. Example of this, at the very beginning the first automobiles were actually slower than horses. And so not many companies jumped into this new industry because they didn't see the potential of a new industry. The second S-curve is the S-curve of technology diffusion. So this is a more market-oriented type of S-curve because this S-curve is assessing how fast users are adopting the new technology. And this will follow the technology adoptance model by Everett Rogers. So with the 5 criteria by Everett Rogers on the adoption of new technology. Interesting factor to recall here is that studies show that technology diffusion is generally takes longer time than information diffusion. So you may wonder why this happens. The reason is that even when companies, in case of B2B adoption, so business to business adoption, or consumers in case of B2C type of adoption, business to consumer adoption, so it happens that companies or consumers might know the advantages of a new technology, but they are still reluctant to adopt this new technology. It could be because of the tacit knowledge that you need when shifting to a new technology, especially if this is a B2B adoption. So if it's a technology for other businesses. So you need the experience sharing, a tacit knowledge, the reflection. This is also important. When people adopt a new technology, then they can reflect on how to utilize the new technology. Important point is also that technology sometimes they require complementary resources, and not always these will be available, and so that's why the adoption might be delayed for a period of time. S-curve are a good way to see the pattern of new innovations. However, keep in mind that it's not one size fits all, so innovation can always develop in a completely different way. So it doesn't mean that when you spot an S-curve, this will continue until the end of the S-curve of technology performance. So there could be some events that will accelerate or that will move users on a new S-curve of adoption and will move companies to a new S-curve of performances. When do we need to switch to new S-curve? So there are four main criteria to consider. So we need to consider the advantages of a new technology. We need to consider whether the new technology is a good fit with the capabilities and especially with the dynamic capability of our firm. We also need to see whether the new technology is a fit with the complementary resources of a firm. And finally, we need to assess the rate of diffusion of a new technology. Combining the S-curve of diffusion with the S-curve of technology improvement, so we can see the impact on economic development and on consumers. So generally, as soon as the S-curve is growing with more learning about the technology improvement and the diffusion, then as soon as this happens, prices will decrease. And this consequently will also accelerate more diffusion of a new innovation. So there is a benefit, a very consistent, significant benefit by analyzing the S-curve of technology improvement and S-curve of adoption, because this will also have an impact on consumer prices and consequently speed up the adoption. Let me now give you an example, a short business case to understand a bit better about all the concepts that we have analyzed so far. The business case comes from Microsoft. Microsoft was a dominant personal computer operating system for almost 30 years. However, what Microsoft was not able to grasp was to become the dominant player of mobile and tablet operating system. And so a possible competitive threat to Microsoft is when tablet and smartphone will become even more high performing than they are nowadays. So then they may eventually replace laptop, and if it so happens, they may also imply that the dominance of Microsoft in the operating system of laptops will end. So to analyze this, we can take a look at these two graphs. So the first one will compare performance versus time. So the performance of a technology trajectory in a period of time. So what we see here is that if a company starts from the mass market position, then will eventually move up into the high end of the market. This matches what we mentioned at the very beginning. Firms generally try to offer higher performances than the mass market expect them to. And the reason is that mass market firms would like to move into the high end of the market. So you can see that their technology trajectory is moving from the mass market to the high end of the market. The second graph is still assessing performance of a technology versus time. But here we have a newcomer in the market. So I think this should remind all of us about disruptive technology, the theories by Clayton Christensen, with a new entrant in the market that is answering a market need in the low end of the market. But as soon as the mass market realizes that the dominant technology is probably overpriced or delivering higher features that they don't actually need, so then the mass market will eventually look for a replacement, and this replacement comes from the low end of the market. So this is to say that when we study S-curve of technology improvement, S-curve of technology adoption, we can also keep in mind what we learn from strategy theories, particularly from the theories of Daveni on the quality and price matching and the value line that company may decide to be in to improve their performances, and the theories by Clayton Christensen on disruptive innovation. Remember that disruptive innovation means either a company coming into the market to serve unmet market needs, or alternatively could be a company that is creating a completely new product or creating a new technology that was not available in the market before, and thus creating also the demand in the market. This is the current situation of Microsoft. So whether Microsoft will be able to react, considering that there are these alternatives, tablet and smartphones coming in the low end part of the market, and eventually may end up replacing laptop, which by the way in many emerging economies already took place, because in emerging economies people generally don't use laptops, but they prefer to use a smartphone or a tablet instead. The very final part of this lecture is on technology cycles. So technology development is a cycle, so there could be always new S-curve coming in and replacing a previous S-curve. Generally there will be a moment of turbulence, of ferment, when there are a lot of competitors proposing different design, different standards. And after this initial moment of turbulence, then we will finally reach a dominant design. When we reach a dominant design, so then all the competitors will follow the dominant design, and they will shift from radical innovation or architectural innovation to incremental innovation. So just to add on the dominant design some additional features that will also increase most likely the price, so move this product into the high end of the market, and consequently give space to low price entrants to step into the market with some new disruptive technology. And this is the end of a cycle when there will be some technology discontinuity and a new technology coming in. I hope you could see in this video the main components of technology development, and particularly what are the typical patterns of technology development using the categorization of different technology. We'll see that the categorization will be based on first radical versus incremental innovation, second competence enhances versus competence destroying, and third architectural innovation versus component innovation, and how these different configuration can be combined with the S-curve of technology performance, S-curve of technology adoption, and finally the battle to establish a new standard in the industry. Thank you for watching. See you in the next video. Bye.